Good evening, everyone. This is G. Om Kedareshwar Kiran from Institute of Aeronautical Engineering, Department of Electrical and Electronics Engineering. Today I am presenting about the algorithms behind modern storage systems and how the algorithms are helpful and what types of algorithms are there in our data structures. Now coming into the slide, algorithms behind modern storage system. The modern storage system rely on a variety of sophisticated algorithms to manage and optimize data storage at scale, from file system management to indexing a search. Here he is saying about the modern storage system relay has a sophisticated algorithms where the algorithms are managed and optimized in a data storage in a scale. The data totally stored or which is managed in a file is indirectly linked with the system management storage and indexing the search bar. These algorithms enable efficient and tolerant high performance data storage solutions. The maximum storage which is efficiently minimized is obviously having a high performance data storage solutions. Now coming to its application, it is different from the terms of reading and writing. It is totally dependent on the workload balance. These applications of files which have been managed in every efficiently storage file system, they are totally balanced on typing or workload balance, which is indirectly linked with the system. Consistency requirements and the access patterns, familiarizing ourselves with database. These all come under database. Storage internal facilities architectural discussions help explain why a system behaves a certain way, help troubleshoot problems when they arise, a fine tunes the database from workload. Here we know that there is a storage or a file which is facilitated in architectural discussions. These architectural discussions of database or data storage algorithm of modern systems help us why a system behaves in a certain way, and we can also troubleshoot the problems which are arising at the time with fine tunes the database on a workload which is totally independent on the certain way where the algorithm behaves on the storage systems. It's impossible to optimize a system in all directions. Yes, it is true. It is really impossible to optimize a system in all directions. That's why we have linked with different routers. In a real world, it is a best example. In an ideal world, there are there would be data structure guaranteeing the best read and write performance with no storage overhead, but of course in practice that's not impossible. Now we can see a picture below that neutral axis 1 and neutral axis 2, it is just a ideal world example. Having two rotors with weak signals have different play signals where the storage is represented in tokens here. There are four tokens. It means there are four storage systems in first router, and there are next four storage systems in second router. Which router has the maximum signal? It has the more tokens and more efficiently facilities of database. We can clearly know that the routers have two storage systems. In first router, the storage system is totally filled and it is neutralized, or neutralized it mean it has a it is what we call it is in steady state. And the second router is not in steady state. It has two weak signals. That's why the field and the storage files are more deviated across first router. Data structures of efficient storage. The data structures of efficient storage are described in different ways. B trees helpful in M sets, I sets, cut sets. But we have took one example here. It is B tree. In a B tree, we provide the efficient indexing and searching for large structured data sets, enabling fast lookups and range queries. Here it is what we're going to say is B-trees provide efficient indexing, the searching of large and structured data sets. The data sets means we know that the data is stored in files where it is indirectly linked to the system, enabling fast lookups and range queries. When the signal is weak, the data storage which is efficiently stored in certain system, it is completely a set of storage modern storage system which synchronizes with algorithms. Here the B tree also a algorithm. Now coming to the binary tree, in a binary tree, every node has two children. Yes, we already know that it is a concept of essence of problem solving. In a binary tree, every node has two children. The binary tree is also called as a parent tree, and left and right subtrees hold keys and are less than the greater than current node key, respectively. To keep the tree depth to a minimum, a binary tree has to be balanced. Now, if we take the two binary trees, the left binary tree having two children means it is divided in, it is giving two children means it is subdivided into two. Left and right should be minimized for a balanced binary tree. In next slide, we are going to see the binary trees, types of binary trees. When randomly ordered keys are added to the tree, it is natural that one side of the tree is eventually get deeper than the other. One way to rebalance a binary tree is to use so-called rotation arranged nodes, punishing and the parent node of the longer subtree down below its child and pulling this child up. The numbers what we call here is so-called rotating the nodes up to down by child up, pulling the child up, efficiently placing it in its parent's position is an example of rotation used for balancing in a binary tree. On the left of an binary tree is unbalanced after adding node to it. After adding two nodes to it, if a binary tree need to balanced, it needs two nodes which are adding to it, indirectly linked up to the parent tree. Sorry, binary tree. In order to balance the tree, node 3 is used to provide the tree rotated around it. Then the node 5 previously root node and the parent node for 3 becomes its child node. After the rotation step is done, the height of the left subtree decreases by 1 and the height of the right subtree increases by 1. The maximum depth of the tree has decreased. Now here we can see the types of the binary trees clearly. In the first type, it is full binary tree. We can see the picture. And the second type, it is complete binary tree, as shown in the picture. And in the third one, it is balanced, totally balanced, with equivalent binary trees and subtrees, which is known as child child class. It is perfect binary tree. And in fourth one, binary search tree. Binary search tree means it locates and allocates the search, binary search. In fifth one, AVL tree. We can see that the AVL tree which is imbalanced the one side and it is imbalanced, totally imbalanced. Now coming to the file management and optimization, there are two types: me- metadata management and generalizing. The metadata management is about the efficient tracking of file attributes, permissions, and access logs of circular for file system performance and security. Now the second one is generalizing transactional. Generalizing ensures file system consistently and quick recovery from crashes or power failures. These and The second one is disk allocation. The disk allocation is an algorithm likes to extend a free space management optimizing how files physically stored in a disk. We know that a disk stores the files where the data is linked up to it. An algorithm which extends a free space management to the data and optimize the data in physical storage disk. Com- Compressions techniques of data storage. Lossless compression, lossy compression, adaptive compression. In lossless compression, techniques like HUMA, HUFMA coding and LZV presents data in integrity and reducing file without losing information. Means in this type of coding, it helps the data size without losing it information. Means the data is not losing its information in this coding in this type of technique. Lossy compression. Lossy compression means algorithm like transform coding and predictive coding trade off some data fidelity for greater compression ratios. Now the third one is adaptive compression. Dynamic compression that adjusts based on a file type is content can optimize storage efficiently. It can in dynamic compression the storage is optimized efficiently based on the file type. Now the next one is indexing a search algorithm. Indexing a search algorithm means inverted index R-trees and graph indexing. The first one is inverted index maps words to the document they appear in enabling fast text-based search. Graph indexing specialized data structures for quickly traveling and query graph data structure. In this, the query graph data structure, the graph indexing is modernized into the data, specialized into a data structure where quickly it can be transformed by querying the graph into a data structure or database. Now the third one is R-tree. In R-tree, special indexing of efficient geospatial queries of location based on the services. Hatching tried storage strategies. Memory hatching, tried storage, eviction policies. These are the three types of hatching a tried storage strategies. In first one, memory hatching, leveraging RAM and the DRAM of the hatch frequently across the DNA or IO input and output server. In the second one, tied storage, the automatically migrating the database between SSD and higher capacity of SSD storage, HDD storage. We already know that SSD storage is higher capacity where it can work fast and give output fast, and HDD is HD storage is little slower in our laptops or the systems which we use. Eventual policies. These intelligent hatches replacement algorithm LUR and FU to maximize hit rises. To develop this HDD and SDD, we use the intelligent replacement of algorithms of LRU and LFU and it is to minimize the rates also. Fault tolerant and data redundancy. In RAID 0, the data is stored by skipping improved performance but no redundancy. In RAID 1, minoring the high availability of data protection directly to the RAID 5 because the RAID 1 consists of 2 and 3. The RAID 5 block level skipping with a distribution of fault tolerance and RAID 6 dually partially increased radiance of resilience. Emerging trends of storage algorithm, computing, quantum computing, numerical computing, and distributed consisting. The quantum-based algorithms are ultra-fast searches and data processing, and numeric computing, brain-inspired algorithms, and hardware for intelligent adaptive storage management is totally on numeric computing. And disputed consequences, these delighting algorithms for secure and tamper-resistant data storage and sharing. The sharing of the data storage is based on the disputed consequences. Now, these are the types of data structures and algorithms which are helped us in modern storage systems. We have discussed all types of data storage systems here. Thank you.